Okay, question 60. What's going on here is we have this matrix M that's factored as a product of a lower triangular matrix and an upper triangular matrix. And what we're asked to do is to find the solution, or I guess the first coordinate of the solution, to the system mx equals this vector b. So this is one of those questions that it's not hard, but it could be time consuming. So our goal here is less to get the answer and more to figure out how we can get that answer efficiently. For example, we could easily calculate M, right? The product of these two matrices, that'd be easy enough to do. It would take a minute, but we could get it. And then we could augment that matrix with this column here and row reduce to solve for x. Nothing tricky going on. It would just take forever. Forever being like, I don't know, 10 minutes or something. So while that would work perfectly fine, I think a better solution is to not find M and instead use the fact that M equals L times U to solve the system L times U, x is equal to B. How would you solve this system? Well, note that u times x is just some vector. Maybe we call it y. So we can solve L times y equals b for y, and then solve u times x equals y for x. That might seem like it'll take a while, but the fact that these are lower and upper triangular matrices will make stuff work out pretty nicely. So let's do it. First, Ly equals b. Here's L, here's b. I want to solve for y. This first row tells me that 1 y1 is equal to 1. Therefore, y1 equals 1. Using that fact, I can figure out y2 because this second row tells me that y1 plus y2 is equal to 0. So y2 must be equal to negative 1. I guess I can show my work a little bit. For this third row, I know that y1 plus y3 is equal to 1. y1 is equal to 1. Sure looks like y3 is equal to 0. Finally, from this fourth row, y1 minus y2 plus y4 is equal to 0. y1 and y2 are 1 and negative 1 respectively. So I have 1 minus negative 1, or 1 plus 1, plus y4 is equal to 0. Sure looks like y4 equals negative 2. So y is equal to 1, negative 1, 0, negative 2. Now that we have this, we can move on to step 2, where we solve ux equals y. Here's u. I'll augment this with y, and I'll use this to solve for x. Because I have an upper triangular matrix here, it makes more sense to start from the bottom. I got 2x4 is equal to negative 2. Therefore, x4 is equal to negative 1. From this row, I know that x3 plus 2x4 is equal to 0. Therefore, x3 plus 2 of these negative 1s is equal to 0. In other words, x3 minus 2 equals 0. Looks like x3 is equal to 2. I could use this row to solve for x2, but I can save a tiny bit of time by recognizing that this first row gives x1 in terms of just x3, which I now know, so I don't even need to solve this row. x1 plus x3 is equal to 1. x3 is equal to 2. Therefore, x1 is equal to negative 1. Negative 1 is answer B. Was there a quicker way to solve this? Probably. Unfortunately, I don't know one. The fact that we only need one coordinate of the vector x kind of leads me to believe that we could have cut out more than just this row here. But it wasn't obvious to me how to do so, and this method really would only take a minute or two on a test. So maybe that's good enough.